Hello everyone, this is Dharamveer sir here. So today we are going to continue with chapter 7 of grade 11 maths, which is permutations and combinations. And the topic of today's video is combinations. Okay, so let's start. Let me explain what is combination. So in the previous video we have learned about permutation. Permutation was arrangement of objects in a definite order. Now combination is also arrangement of objects, but in combination order does not matter. Okay, so on the occasions when we are not interested in the arrangement, okay, but only about selecting R from n objects, then we use combination. So combination is a selection of some or all of a number of different objects where the order of the selection is immaterial, that is, the order does not matter. Okay, so the selection of R objects from the given n objects. So we are selecting R objects out of n objects when the order does not matter is given by NCR, that is combination of R objects out of n objects, and this is equal to factorial n upon factorial R into factorial n minus R. So simply putting the value of n and R and using the properties of factorial, we can find the different combinations. Clear? So pause and note down the definition. Now few important points related to combinations. So let n and r be positive integers such that r is less or equal to n. Now we know that r cannot be greater than n. Then first is NCR will be equal to NCn minus r. How? If you simply apply the definition of combination in both the sides, you will get that both are equal. Second is NCR plus NCR minus 1 will be equal to n plus 1 CR. NCR plus NCR minus 1 is equal to n plus 1 CR. You can verify this simply using the definition of NCR. Then third is n into n minus 1 CR minus 1 will be equal to n minus r plus 1 into n CR minus 1. You can also verify this by using simply the definition of NCR. So n into n minus 1 CR minus 1 is equal to n minus r plus 1 into n CR minus 1. All of these three properties can be verified by using the definition of NCR, that is factorial n upon factorial r into factorial n minus r. Clear? If you want, you can verify them. So pause and note down these important points. So let's start exercise 7.4, and the question 1 is, if NC8 is equal to NC2, then find NC2. Now NC8 equals to NC2, so by using the property that if NCP is equal to NCQ, then either P is equal to Q or P plus Q is equal to N. Now here 8 cannot be equal to 2, therefore using the second one, that is P plus Q equals to N, we get 8 plus 2 is equal to N, that is n equals to 10, therefore NC2 becomes 10C2. So you can simply write this as 10 into 9 upon 2 into 1 by using the property of NCR, that is factorial 10 upon factorial 2 into factorial 10 minus 2, which will be equal to 45. Clear? So here we have used the property NCP is equal to NCQ, will imply that either P is equal to Q or P plus Q will be equal to N. Okay, so pause and note down the solution. Next is question 2. Determine n if, now there are two parts, I am solving the second part for you, that is 2nC3 ratio nC3 is equal to 11 ratio 1. So 2nC3 can be written as 2n into 2n minus 1 into 2n minus 2 upon 3 into 2 into 1, and nC3 can be written as n into n minus 1 and minus 2 upon 3 to 1. So writing this, we get 2n into 2n minus 1 into 2n minus 2 upon 3 into 2 into 1 ratio n into n minus 1 into n minus 2 upon 3 to 1 equals to 11 ratio 1. So on simplification, we will get 4n into 2n minus 1 into n minus 1 upon n into n minus 1 into n minus 2 equals to 11. So again simplifying, we get 4 into 2n minus 1 upon n minus 2 equals to 11. So cross multiplying, we get 4 into 2n minus 1 equals to 11 into n minus 2, which is equal to 8n minus 4 equals to 11 and minus 22. So on solving, we get n equals to 6. Clear? So pause and note down the solution. Next is question number 3. How many chords can be drawn through 21 points on a circle? Now we know that in 3 points on a circle are non-collinear. A chord can be drawn by joining any two of the 21 given points. Okay. Now here if you take the point AB or point BA, so in this sum order does not matter. So this arrangement depends on the combination, not on permutation. Clear? So the number required chords will be 21 C2, because for one chord we need 2 points out of 21 points. So this the required chords will be 21 C2. So which is equals to 21 into 20 upon 2 into 1, that is 210. So we have used the definition of NCR, that is factorial 21 upon factorial 2 into factorial 21 minus 2. Clear? So pause and note down the solution. Next we have question number 4. In how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? Now 3 boys out of 5 boys can be selected in 5C3 ways, and 3 girls out of 4 girls can be selected in 4C3 ways. Therefore by the multiplication principle or the fundamental principle of counting, the total number of ways of selecting the team will be equal to what? 5C3 multiplied by 4C3. So we get 5C2 into 4C1, which is equal to 5 into 4 upon 2 into 1 into 4, which is equal to 40. So in 40 ways we can select a team of 3 boys and 3 girls from a 5 boys and 4 girls. Clear? So pause and note down the solution. Next we have question number 5. Find the number of ways of selecting 9 balls from 6 red balls. 9 balls from 6 red balls, 5 white balls and 5 blue balls. If each selection consists of 3 balls of each color. Okay, so we are selecting 3 balls of each color. So 3 red balls out of 6 can be selected in 6C3 ways. 3 white balls out of 5 can be selected in 5C3 ways, and 3 blue balls out of 5 can be selected in 5C3 ways. So again using the fundamental principle of counting or the multiplication principle. So the 9 balls will be selected in simple multiplication of these 3, 6C3 into 5C3 into 5C3, which can be written as 6C3 into 5C2 into 5C2. Why? Because NCR equals to NCN minus R. Clear? So simplifying this, we are getting 6C3 equals to 6 into 5 into 4 upon 3 to 1. 5C2 equals to 5 into 4 upon 2 into 1, and 5C2 equals to 5 into 4 upon 2 into 1, which gives 20 into 10 into 10, that is 2000 ways. So in 2000 ways we can select 9 balls and 3 balls of each color. Clear? So pause and note down the solution. Next is question number 6. Determine the number of 5 card combinations out of a deck of 52 cards. If there is exactly one ace in each combination, so there have to be one ace. Now we know that the deck has 52 cards, 4 are aces and 48 are other cards. So one ace out of the 4 can be selected in 4C1, and the remaining 4 cards, because we need 5 cards now and we have already selected one ace, so remaining 4 cards have to be selected from 48, and this can be done in 48C2 ways. So again by the fundamental principle of counting or the multiplication principle, the total ways will be equal to 4C1 for the ace multiplied by 48C4 for the remaining 4 cards, which is equal to 4 into 4C1 is 4, and 48C4 equals to 48 into 47 into 46 into 45 upon 4 into 3 into 2 into 1, which is equal to 778320. Clear? So pause and note down the solution. Next we have question number 7. In how many ways can one select a cricket team of 11 from 17 players in which only 5 players can bowl, if each cricket team of 11 must include exactly 4 bowlers? Now we have to select 11 players out of 17 players, and out of these 17 we have 5 bowlers, and the remaining will be, that is 17 minus 5 will be, that is 12 will be other players. Now 4 bowlers out of 5 can be selected in 5C4 ways, and the remaining we need 7 more players. Okay, and the remaining 7 have to be selected from the remaining 12. So we have 12C7 for the other 7 players. So again using the fundamental principle of counting or the multiplication principle, the cricket team of 11 out of 17 can be selected in 5C4 for the 4 bowlers and 12C7 for the remaining 7 players. So multiplying these two, now 5C4 can be written as 5C1 and 12C7 can be written as 12C5 by using the property NCR equals to NCN minus R. So 5C1 equals to what? 5, and 12C5 can be written as 12 into 11 into 10 into 9 into 8 upon 5 into 4 into 3 into 2 into 1, which is equal to 3960. Okay, so there are 3960 ways of selecting the 11 players. Clear? So pause and note down the solution. Next is question number 8. A bag contains 5 black and 6 red balls. Determine the number of ways in which 2 black and 3 red balls can be selected. Now 2 black balls out of 5 black balls can be selected in 5C2 ways, and 3 red balls out of 6 can be selected in 5C3 ways. So again, by the fundamental principle of counting or the multiplication principle, the required number of ways will be 5C2 into 6C3. So 5C2 equals to 5 into 4 upon 2 into 1, and 6C3 is equal to 6 into 5 into 4 upon 3 into 2 into 1, which is equal to 200 ways. So there are 200 ways of selecting 2 black and 3 red balls out of 5 black and 6 red balls. Clear? So pause and note down the solution. Next is question number 9. In how many ways can a student choose a program of 5 courses if 9 courses are available and 2 specific courses are compulsory for every student? Now, since 2 courses are compulsory, so student has to choose 5 minus 2, because total 5 courses, and since 2 are compulsory, so remaining 3 courses he has to choose out of remaining 7. Out of 9, 2 are compulsory, so 7 are remaining. So he has to select 3 courses out of 7 remaining courses, and this can be done in 7C3 ways. And 7C3 equals to what? 7 into 6 into 5 upon 3 into 2 into 1, which is equal to 35. Clear? So pause and note down the solution. With this, we end exercise 7.4. So solve the sums of the exercise and also the examples given before the exercise. Thank you and all the best.